Okay, first thing we're going to have a look at with this Maths for Science course then is scientific notation. The scientific notation is also known as standard form. Now that is just two names for the exact same thing, there is no difference between them. And it is a special way of writing very large or very small numbers using powers of 10. It's very useful in science if you're looking at very large numbers like the distance between the Earth and the Sun, or very small numbers like the radius of a hydrogen atom. Okay. If we start by looking at large powers of 10 then, if we think of 100, 100 is 10 times 10, which is 10 to the power of 2 or 10 squared. 1,000 is an extra 10 there, so this time we've got, helps if I've got my pen working, doesn't it? 1, 2, 3 tens, we get 10 to the power of 3, 10,000, 4 tens, so 10 to the power of 4, 100,000, 5 tens to 10 to the power of 5. And obviously that's just going to continue. Every time I add an extra 10 on, I add an extra number on here as well. Okay. If we think about that in terms of numbers other than a 1 at the beginning, 200 is 2 times 100. That 100 was written as 10 to the power of 2. So that 200 becomes 2 times 10 to the power of 2. So 300 would be 3 times 10 to the power of 2. And this is the shorter way that we use to write numbers using standard form or scientific notation. 4,000 is the same as 4 times 1,000, which is 4 times 10 to the power of 3. 6,000 be 6 times 10 to the power of 3. Hopefully we're getting the idea now. 20,000, don't think about it as 20,000, think about it as 2 and then 1, 2, 3, 4 zeros, so it would be 2 times 10 to the power of 4. 80,000 would be 8 times 10 to the power of 4, move this up slightly. 900,000 would be 9 times 10 to the power of 1, 2, 3, 4, 5. And 2 million would be 2 times 10 to the power of 6. Okay. Looking at small numbers then. If we're looking at small numbers, we're looking at numbers like 0.1, 0.01 and so on. 0.1 is 1/10, which can be written as 10 to the power of minus 1. Okay, we will look at that rule in more detail in outcome 2. This part we just need to accept that if we're dividing by 10, we make our power a negative. So 0.01 would be 10 to the negative 2, 0.001, 10 to the negative 3. And what it really is it's how many times I've taken that 1 and divided it by 10. So I've done 1 divided by 10, divided by 10, divided by 10, get to this 1 over 10 cubed, which is 10 to the minus 3. Okay. With some other numbers then, 0.2 would be 2 times 10 to the minus 1, because it's 2 times the 0.1, and the 0.1 is 10 to the minus 1. So 0.03 will be 3 times 10 to the minus 2, because it's 3 divided by 10 2 times. Hopefully you're seeing the pattern now. So this will be 5 times 10 to the minus 3, 8 times 10 to the minus 4, 4 times 10 to the minus 5, 7 times 10 to the minus, just check I haven't put an extra one in here. No, it's still 6. And the last one, 2 times 10 to the power of minus 1, 2, 3, 4, 5, 6, 7. Okay. In general then, any number can be written into scientific notation. And the rule is, the first number here needs to be a number that's between 1 and 10. So it can be 1, but it can't be 10. It needs to be a single digit. So it can be 1, 2, 3, 4, 5, 6, 7, 8. It can be 3.8, 4.5. It can be 9.99, but it can't go all the way up to 10. And the reason for that is I want it in times 10 to the power of. So if I go to 10, that essentially is adding on an extra power here. We need the times 10 because that's what we're timesing it by. We're timesing it by 10, however many times this power says. And my value of n here must be a whole number, and it can be either positive or negative. It's positive if it's a big number, negative if it is a small number. Okay, how we do this in general then? We've got a decimal point that we need to move, and we're always going to move that decimal point so it lies between the first two figures. That's to get my number between 1 and 10. That's to get my starting number. The second part, I then count and see how far I've moved the decimal point. If we've moved it to the left, it's positive. If we've moved it to the right, it's negative. Right, let's try some. First one, change the following to standard form. So the first thing we're going to do is we're going to put in our decimal point, and the decimal point is always to make a number between 1 and 10, so it's always going to go in there. So I've now got 8.3, and I want to know how many spaces I've moved it. So my decimal point was here after the 0, because every number has an invisible decimal point, and I've moved it to here. So I've moved it 1, 2, 3 spaces. So to get that number back to where it was, I missed out my 7 there, I need to move it 3 spaces this way, so that would be times 10 to the power of 3. The next one, my decimal point is going in here. I don't need my point, it's just 0 times 10. It was here, so I've moved it 1, 2, 3, 4, 5, 6 spaces. See, put my decimal point in here, it becomes 6.7 times 10. I've moved my point 1, 2, 3, 4, 5 spaces. 4.8 now, it's not the kind of number you would normally write into standard form of scientific notation, because obviously if you're writing it into standard form, it takes a lot longer than just writing 48, but we can still have it in standard form. Okay, so we've got our 4.8 times 10, and I've only had to move my decimal point once. And normally I would tell you that we don't need a 1 in there, but for standard form it looks better. Okay. E, the decimal point's going in here. Still get the rest of my number. Still move the decimal point though. I've moved it 1, 2, 3 spaces. Get times 10 to the power of 3. Last one, the 56,003. My decimal point goes between my 5 and my 6. Keep the zeros in, keep the 3 in. We're not rounding the number. We're keeping it the same. And that would be times 10 to the power of, moved it from here, 1, 2, 3, 4. Okay. Any questions at this point, please send me an email, let me know. I can always jump onto Zoom and go over some with you. Okay. Doing it back the other way then. We looked at writing into standard form. Now I want to write them back into normal form. So looking at the first one. First thing I want to do is get rid of my decimal point. To get rid of my decimal point, it's taking up 1 space. I've got 2 left, so I'm going to add these in with zeros. Next one, 7.43 times 10 to the power of 6. I'm going to take 1, 2, those 10s to get rid of my decimal point. So I've got 4 left. You can always do a check. My decimal point was here, I've moved it to the end, so 1, 2, 3, 4, 5, 6. Moved it 6 spaces. Part C, 2.07 times 10 to the power of 2. It's going to take me 2 10s to move that decimal point, so I don't need to add any zeros this time. 5.47 times 10 to the power of 5. There's 1, there's 2, 3, 4, 5. 9 times 10 to the power of 1 would just be 90. And 2.134 times 10 to the power of 2. There's 1, there's 2. Need to keep my decimal point in this time. I don't have enough to completely get rid of my decimal point, so I've moved it 1, 2 spaces, so I get 213.4. So that's the big numbers then. That's how we write numbers from standard form to out in full with big numbers with a positive power. Let's try small numbers. So looking at small numbers then, we're still doing the same thing. We still want to move our decimal point. So they get a number between 1 and 0. Sorry, 1 and 0, 1 and 10. But remember that needs to then go past the number. I would need my decimal point in here. So it's going to be 9 times 10. I've moved it 3 spaces. It's a small number, so I make it negative 3. Part B, move my decimal point 1 space. So I get 2 times 10 to the power of minus 1. Looking at C, I want to get my number between 1 and 10. It's not right to the end of the number. It's just between that 4 and the 9. So we get 4.98. I've only moved it 1 space. So we get times 10 to the power of minus 1. D, the number between 1 and 10 is going to be my 5.4. I'm going to times 10 to the power of, and this is where we need to do careful counting, especially on a computer screen. 1, 2, 3, 4, 5, 6, 7, 8. Remember the minus for it being a small number. So 5.4 times 10 to the power of minus 8. E, 5.06. So my decimal point's going to here. I've moved it 1, 2, 3, 4 spaces. Last one, I want to move my decimal point to here, so we get 8.6321 times 10 to the power of minus, I've moved that point 1, 2, 3 spaces, so we get times 10 to the minus 3. So with small numbers, the power is always the number of zeros at the start of the number. Okay, so if we have a look at the first one, it's times 10 to the minus 3, we've got 1, 2, 3 zeros. Second one, 1 0 at the beginning, minus 1. D, we've got 1, 2, 3, 4, 5, 6, 7, 8 zeros, times 10 to the minus 8. Looking at E, I don't count a 0 here, it's just the ones at the start. So we have 1, 2, 3, 4. That rule is very useful for writing it back the other way. Okay, then when we're looking at this one, I've got a minus 3, so I get 0.00, that's my 3 zeros, 4, 1. Looking at B, I've got minus 5, so 0.0000, and then I add in my number, 872. C, I get 0.03005, excuse me. D, times 10 to the minus 5, so 0.00005312, and you can always check this. I have moved my decimal point from here, so I've moved it 1, 2, 3, 4, 5 spaces. E, but 0 times 10 to the minus 2, so we get 0.08, and the last one times 10 to the minus 4, so we get 0.000, and I've got my 4 zeros, and then I just fill in the number, 70909. Okay, there is a worksheet for you to try to practice some of these, writing them back between standard form and writing it out in full. As ever, please don't wait until we're meeting on Zoom. If you have any issues, please email me and I'll get in touch as soon as I can. Okay, speak to you soon.